Hi there, this is Jacob Nash, and in this video we'll be going over related rates. We'll just be going over a few problems here. There's so many different questions that can be asked, so there's no way I could just have every possible example, but I have four that should cover like varying types. Um, so first of all, what kind of problems are these? How will you know if it's related rates? Well, there are always word problems, and you're trying to find the rate of change of something, which essentially means that we're finding the derivative of something. So something prime. And usually it's something like length, volume, angle, anything, any kind of variable that might be in any shape equation that you might know. The thing about these problems is the formula should be provided to you, but I can't say that's the case for every calculus teacher out there. So that's up to you whether you know if you need to memorize certain formulas. But I should say that what you definitely want to remember is SOHCAHTOA, Pythagorean theorem, and area of a square, area of a circle, area of a rectangle, but more complex things like law, cosines, volume of a cone, or something like that, like I would hope would be given to you because that's kind of tricky to memorize. But do what you will for that. But what we are doing every time is we'll do DDT because it's always with respect to time. That's what it means, rate of change. A formula that fits the problem to find the variable we need. So it'll make more sense when you see. But the steps to solving is I always use this format like for almost any word problem in math. It's always good to use this method. It's KNES. Well, first though, for these, you're going to want to draw what it's like. So that's kind of like a first step. But then you just want to write what you know, everything that they tell you in the problem, just like a list. Then write what you need to find. And this might seem so straightforward, but it actually really can help you determine, because sometimes the hardest part is just knowing what it means. Like, okay, what does this mean? What value is that? And this helps you organize it. Then you write what equations or formulas you will need because you're probably going to have to find something that they didn't tell you. Not only that, like I said, we take the derivative ddt of the formula that we use. Then, last thing, solve that thing by taking ddt of the formula. Let's look at the classic example. Wow, you might have seen this before. Streetlight. It's so annoying, but it's not so bad. It's not so bad. So let's just read it first, okay? This looks like a horrible problem. A 5-foot woman walks at a rate of 2 feet per second away from a streetlight that is 21 feet above the ground. At what rate is the length of her shadow changing when she is 7 feet from the light? At what rate is the tip of her shadow moving when she is 7 feet from the light? So the first thing that I would think when I see is first, I hate this because it's asking two things. That's the first thing. That's annoying. Second thing is it's just kind of lo lengthy. That's why we want to do the thing where we write what we know and what we need to find. You know what I mean? So first, let's draw that thing. So for me, and I'm sorry this is like on the slideshow format, but I I see two triangles here, okay? That's the way that you should always look at this. I see a small triangle right here, and I see a big triangle right here. Both are right triangles. So we at least know we might have a Pythagorean theorem on that's my first thought, which as it ends up, we don't use that. But that's what my first thought would be. Maybe I'll have to use Pythagorean theorem. Maybe I'll have to use trigonometry. They don't give us a formula in this problem, so we'll just have to figure it out on our own what we need to do. But we have 21 is the length of the whatever you call it, street light. And then she's 5 feet tall. Obviously, this isn't the scale, but that doesn't matter. Um, but that's really all I can do. Like, if I'm drawing this, I mean, that's all I know is what to do right now. Like, but I'm just gonna write what I know. So I'm gonna say Um, okay, y1 is 21 feet. So I'm calling this y1 right here, the length of the stoplight, street light, sorry. I'll call y2 the height of her. And I say y just because I usually think of y as height, right? And then I'll call this distance between the light and her x1, and the distance between her and the tip of her shadow x2. So by the way, the reason why we have it like this is, oops. The reason why we have it like this is because her shadow, where the shadow always goes away from the light, right? That just makes sense. So that's why we have to draw it like this, like a triangle. So we know why we were given y1 and y2. X1 is 7 feet because it's saying when she's 7 feet from the light. That's what it says here, and that's what it says here. So I know that X1 is 7 feet. I have no freaking clue what X2 is. I don't know if that's cut off for you as well, but I'm sorry if you can't see that. But that's supposed to say X2 is question mark. I don't know what that is. I do know that it's gave us a rate of change. Anytime there's a rate of change, we know that's a prime something. Which prime is actually X1 prime because 2 feet per second away from the street light. So that's the change in X1. And it's positive because she's going away from it, so it's getting bigger. So that's important. Positive, negative matters. So we just wrote what we knew. Now let's write what we need to find. Well, the first part of the question is asking the length. And by the way, of the four problems, this is the hardest one in my opinion. So I don't know why I did it first. Sorry about that. But um, what rate is the length of her shadow changing? So length of her shadow, that is going to be just this x2 part right here. See? x2. That's the length of her shadow and the rate of change of it. So x2 prime. The second part says the tip of her shadow. So that's specifically this part. And this is a part that's kind of confusing, but that's actually going to be this whole part, x1 plus x2. So the prime of that. So that's okay. We got through this thing, two things. We're kind of like 50% done. Now let's write what equation we need. And here's where a lot of people get stuck. This is exactly why I have this problem here. Do we use Pythagorean theorem? No. SOHCAHTOA? No. We actually use a proportion because similar right triangles, that's just something you'd have to know, unfortunately. But if we have two triangles, whoa, if we have two triangles that are within each other like this thing is working horribly. I apologize. See this? So they have the same angle right here. They're actually proportionate to each other. So we created a proportion. As you can see here, that's what I did. I have 21, and oh my gosh, I apologize. This was supposed to be a 5, which means this is also supposed to be a 5 right here, which means this is wrong. So let's just pretend the question said she was 6 feet tall. I apologize for that typo. That's going to be messed up everywhere. So pretend like that was a 6. 666 everywhere. Yeah, I didn't mean to say 666. Sorry about that. Whatever. Um, so proportion 21 over x1 plus x2. So that's the big one, right? So that's this over this is equal to this over this. That makes sense, right? So this is x1 plus x2 full length and then 21 6. So that's just a proportion. We would have to solve for x2. Um, you know what? Actually, as it turns out, see, sometimes you don't even need things. So we don't actually need x2 because that's not what we're trying to find. We're trying to find x prime 2. And as it turns out, we don't need x2 to find x prime 2. Um, but this is what equation that we created that we will take the derivative of because that's what our goal is, to take the derivative of an equation. So this is one of the hardest related rates questions you could get. So this is the equation that we're taking derivative of. So we solve. We do d dt both sides. See this? We d dt both sides. Now, look what we have here. The derivative of x2 is just x2 prime. The derivative of this, we put this thing to the side, and then it's x1 prime. Because you see these aren't two functions multiplied. We don't have to do product rule. So we know what x1 prime is 2. We multiply it by what we found right here from doing the proportion. And as it turns out, the answer is 5 feet per second. So see, that actually wasn't that bad. You just have to know to create this proportion and make it in terms of x2, and then take the derivative of it. Sorry. Now, for the other part, all we have to do is add them together because the derivative, I remember I said that's the tip of foreshadow, that's going to be them added together. So we have 2 plus 5 is 7. Now keep in mind, if this part right here didn't say 7 feet from the light, we would have to do this again. Um, and it wouldn't be the same. So notice that those are both parts say she's 7 feet from the light. If it was different, we wouldn't be able to just add it like that. But if they made it different, that would be kind of rude. So that was the first one. So let's now go on to the second question, which is, in my opinion, easier. The radius of a sphere is increasing at a rate of 5 millimeters per second. How fast is volume increasing when the diameter is 50 millimeters? So first, let's draw it. I see a sphere right here. I don't know, not much to draw, honestly. Let's write what we know. There's only two numbers we're given. If you notice, what I have down here doesn't look the same, right? Um, yeah. Well, one of them is not. I don't know how there's so many mistakes in this. I apologize. So once again, we're going to just pretend like the number is something different than it is. 4 millimeters per second. That's the change in the radius. Now, they gave us a diameter to try to kind of confuse you and make you get it wrong. Of course, that's what they always do. So you have to make sure you put 25 because the volume is what we're trying to find. The change in the volume, see how fast is volume increasing? And the volume of a sphere is this equation, which hopefully you would be given. If you're not, just memorize it. But as you can see, there's no diameter in the equation. That's why we have to make sure it's radius. So that's the equation. Now we just take the derivative of the equation. And the derivative of v is v prime. And then we put this to the side, 4 pi over 3. The derivative of r cubed is 3r squared r prime. Oh my gosh. This annotation thing does not work well for Zoom. My videos suck, if you haven't realized by now. You know why that I have to do this? Because my freaking iPad won't let me use YouTube anymore. Oh my gosh. What is this thing that just popped up? Okay. Okay. I'm just trying to draw a 2 and it will not let me. Okay, r squared. So that means they're supposed to be squared there too. Um, you don't always have to simplify depending on the professor. In my opinion, you're not able to use a calculator. Why simplify? So that's the answer. We solved in terms of v. We plug in r and r prime, and that's our answer, as you can see. So that's not that hard. So we just basically write what we know. What do we need to find? What equation can we use? And we take the derivative of it, plug things in, and that's how we get our answer. Okay, next question. At noon, a truck is truck A is 200 kilometers west of truck B. Truck A is driving east at 40 kilometers per hour, and uh, something's blocked. Truck B is driving north at 25 kilometers per hour. How fast is the distance between the ships changing? Once again, that's a lot of crap right there, so let's go ahead and draw it. Sometimes drawing doesn't even really help that much. In this case is an example of that. There's not much we can say because we'll have to find some things on our own. So let's just go ahead and write what we know. And I kind of skipped some steps here just for time's sake, but let's just stick with what we were actually specifically told. We were told X prime and Y prime. It doesn't matter what letters you use. I just decided to do that because there's essentially a triangle we have here. Z prime is Z is the distance between them. Z prime is the change in distance between them, which is what we're trying to find. I just chose X and Y for those. So the change in X, the change in distance between them horizontally, we were told is 40 kilometers per hour. Um, because truck A is driving east. I put negative because the distance between them is decreasing. That so does that make sense? Because it's going east, so it's going towards it, so the distance is decreasing. The change in distances. Um, sorry, that's actually wrong. The distance between them is um decreasing. Well, so this is where it gets a little bit tricky because that kind of depends on whether you consider it speed or velocity, whether you include positive or negative. Right now I'm going to stick with negative because the distance between them is the distance is decreasing in that aspect, in the X aspect, because it's going east. That means towards it. So we'll stick with that. Okay. This question is kind of vague in terms of that. So that's, yeah, sorry about that. Um, change in Y, it goes north at 25 miles per hour. So Y prime is 25 kilometers per hour. Now, how do we figure out X and Y? Well, it told us, okay, we're saying at noon and then at 4. So that's 4 hours. So I say, okay, well, the distance, um, truck A is 200 kilometers west at noon at 4 p.m. That's 4 hours. I multiply it by how fast it's going. So I do 4 times 40. So in 4 hours, the distance decreases by 160. So I do 200 minus 160 to get 40. I apologize that I'm going through this kind of fast, but I really just don't have time to like go into much more detail than that. But I hope you can understand what that means. Like if we're starting out at 200, 4 hours go by of it going 40. So that's why we subtract 40 times 4. And we get 40 is the distance at 4. So that's what matters, right? Instantaneous at 4. So 40. And then for here, it is for 4 hours going 25 miles per kilometers per hour, sorry. So 100 kilometers. That's how I got that. How did I get Z? I did a Pythagorean theorem. I hope you know that. So I just took a shortcut, but I'm leaving it in this format because usually you're not allowed to use calculator in this class, and I'm not about to try to figure that out. 40 squared, 100 squared. That's just stupid. And any professor that takes off points for you leaving something like this when you can't use calculator is a stupid person. Sorry about that, but hopefully you're allowed to leave it like this too. So that's what we know. And keep in mind, it only took this long because I'm saying it. It would hopefully be quicker for you when you're doing it. We're trying to find z prime, as I said, because it's the distance between them is z. The change in distance between them, which is what it asked, is z prime. The equation we use, Pythagorean theorem. We will take the derivative of both sides. We would get 2xx prime plus 2yy prime equals 2zz prime. Solving for z, we would just divide by 2z to get z prime by itself. We plug in all the values we know, including that stupid thing, and I leave it unsimplified because once again, I don't see why there's any point in you. There's no way that is not a whole number, just to let you know. So that's why it's pointless, in my opinion, to simplify it. Um, and this tells you, so if you want to simplify it, you can, but I'm leaving it as this because I don't see a point. Okay. That's just my opinion. Now, our last question. Um, a boat is pulled into a dock by a rope attached to the bow of a boat passing through a pulley on the dock that is 1 meter higher than the bow of the boat. If the rope is pulled in at a rate of 1 meter per second, how fast is the boat approaching the dock when it is 8 meters from the dock? I apologize if you hear that loud bird out my window. Sorry. Once again, doesn't this seem like an annoying problem, right? That's why we draw. Okay, this is one where drawing is useful. So we have the boat right here, pulley up here. That's a terrible one, but it's 1 meter higher. The distance here is 8. This is the dock. This is the rope. So the hypotenuse is a rope. Keep that in mind. What do we know? We see a triangle right here. I hope you can see that. Every time there's these problems, it will create a shape, right? So let's say that, like I said, it doesn't matter which you use as X and Y. If you did it differently, that's fine. But this is X, 8, Y is 1. We were given that. Z, I would use the Pythagorean theorem to find that, and it ends up being square root of 65. So that's what this length is here. X prime is actually what we're finding this time, not Z prime, because see, how fast is a boat approaching the dock? That's right here. We were told the rope is pulled in at 1 meters per second, so that's Z prime. We're trying to find X prime. Now, why is Y prime 0? Because the distance right here is not changing. It's always going to be 1 meter higher. That's just supposed to be assumed. And that's where these questions can be hard because, but you just have to think about that. Like they didn't tell you it, there's no way you could find it, so we should assume it's staying the same, even though it doesn't say that, which it should, in my opinion. But it's 1 meter higher. We're going to assume that doesn't change. And so it's 0. There's no change in it. We're trying to find X prime, as I said. We'll use Pythagorean theorem equation and we'll take the derivative of it once again. And it's the same as last problem. Luckily, if you might do this so many times that you'll know it's just always 2xx prime plus 2yy prime equals 2zz prime. This time we're solving for x prime, so we'll move this to the other side, the 2yy prime, and then we'll divide by 2x. I'm sorry that I'm skipping some algebraic steps, but that would make this video really long. Um, I have so many videos if you are not familiar with how I'm doing this, but I'm just getting x prime by itself. I subtract that term on the other side, I divide by 2x. That ends up being square root of 65 divided by 8 meters per second. So that's the end of this last example on here. So once again, needless to say, this video, I kind of skipped some steps and there might have been some things left unclear. So if that's the case, I would really suggest that you watch any video that I might have, or there are other videos out there that go more in depth, but this is supposed to be more like of a review. But the bottom line for these problems, like I said, you're going to want to draw it. You write everything you know. Oftentimes, there's something that you have to figure out your own. You weren't told that this was 0, for example, but I know that it is. You weren't told this Z value, but you had to use Pythagorean theorem to find it. So there will be things like that. There are like roadblocks in the way. You figure out what you're trying to find. The only way you could know that is by um, drawing it and figuring out what it's asking. Equation, whatever equation that you can think of that applies and you know all the variables of. I know X, I know Y, I know Z. That's why this is the equation we use. And then you take the derivative of it, d dt. So there's always going to be the primes, right? That's implicit differentiation. And then you solve for whatever it is. So at the end of the day, like the process is easy, but what makes these hard is just you trying to figure out what each thing is. Now, there wasn't any example in this video where I had angle. Sometimes that's the case. You would have to find the change in the angle. For that, you would want to use a SOHCAHTOA equation, or maybe even law of cosines or something like that. And you could also even have problems that are a little bit trickier where it would say like, you're draining the volume and something like that. Like there's lots of different types of problems that I just can't go over every single one, but just practice as many as you can and you'll get better. And um, I hope this video helped in some way. So that will be it. Thank you for watching.